Okay, we're going to move into a new area of study here with Chapter 4, where we discuss the study of trigonometry. And to be honest with you, this lecture is perhaps the most important for the entire class of pre-calculus because it is so important when it comes to your success in calculus. And so please make sure that what we do in this section makes total and complete sense to you, because if not, it will really put you back when you get to your calculus class. And so what I've done is I've tried to pare this down and make it as simple as possible, and I'm trying not to bog you down in a bunch of details, but I want to try to make this as clear as I possibly can so that it will make sense for you. And so the first thing that I feel like we have to talk about is how to convert different angle measures between radians and degrees. And so you've been talking about degrees for a long time in math. And so you probably know that if you have a straight line, that a straight line is defined as 180 degrees. But what you may not know is that 180 degrees is the same thing as pi radians. And so that is a conversion factor that we are going to use here at the beginning of the notes in order to convert between different angle measures. And so to convert from radians to degrees, what you're going to do is multiply by 180 divided by pi. That's going to take something that's in a radian measure to a degree measure. And if you want to convert from degrees to radians, you're going to multiply by the reciprocal of that conversion factor, pi over 180. And so what we're going to do in the first part of the notes is just practice converting between these two angle measures, between degrees and radians. And I'm just going to tell you up front that it's more important that you're comfortable in radians, because in the study of calculus, everything is done in radians. We sort of forget about degrees whenever we get to calculus. Okay, so we're going to work several examples here just so that you can get a good feeling for how this is done. And so in letter A, we're given the angle measure 225 degrees. And so to convert that to radians, I'm going to multiply by pi over 180. Now that's going to give me 225 pi divided by 180. And what you want to do from there is you want to take just the fraction part of that, so leave out the pi, and you want to try to reduce that. And so when you reduce 225 over 180, what you're going to get is 5/4. And so this is going to become what we would call 5 pi over 4. Okay, letter B, pi over 6, that is currently a radian measure, and so to convert that to degrees, we would multiply by 180 divided by pi, and whenever you do that, the pi's are going to cancel, and so what I'm going to end up getting then is 180 divided by 6, and that is going to reduce to 30 degrees. Now that is a very important angle that we are going to talk about more often in this class and more in these notes later on, and so that's probably one that you want to memorize, that pi over 6 radians is the same as 30 degrees. Now letter C, we've got 5 pi over 3, and so when we multiply that by 180 over pi, then that's going to convert it into degrees, and so this is going to end up being 300 degrees whenever you simplify. Okay, 120 degrees, if we were going to convert that to radians, that would be pi over 180 is what we would multiply by, and so that's going to be 120 pi divided by 180, and we're going to take just the fractional part of that, just the numerical part, leave the pi out of it, because we want to leave our answer in terms of pi, and 120 over 180 reduces to 2/3, and so this would just be 2 pi divided by 3. Now letter E is 300 degrees. We already know from part C back up here that that should be 5 pi over 3, but let's just verify that by multiplying by pi over 180, and so that's going to be 300 pi divided by 180. If I just take the fractional part of that, 300 divided by 180 would reduce to 5/3, and so this will equal to 5 pi over 3. Okay, and then finally letter F. This is another one that you're going to want to memorize along with letter B. And so letter F here, pi over 4, we're going to multiply by 180 divided by pi. That means your pi's are going to cancel out, and 180 divided by 4 is going to give you 45 degrees. And so pi over 4 radians and 45 degrees would be the same angle. Okay, here in G, H, and I, I'm going to start introducing some new concepts here. And so I'm just going to draw a coordinate plane and tell you that every angle on the unit circle, which is what we're studying in this section, is how to find values on what is called the unit circle. And what that is will become clear over the course of the notes. Every angle starts on the positive x-axis. And so this is 0 degrees, or also 0 radians. And so now I'm going to move into these examples and kind of show you where these angles would appear on this coordinate plane. And so for pi over 2, we're going to multiply by 180 divided by pi. That's going to make your pi's cancel, and you're going to get 180 divided by 2, which is 90 degrees. And so every angle that is positive is going to rotate in the counterclockwise direction. So starting here at 0, if I rotate counterclockwise 90 degrees, that is going to put me on the positive y-axis. And so this is 90 degrees, but it's also pi over 2 radians. And so every angle between 0 and 90 is going to be here in quadrant 1. And so just as a reminder, we call that upper right quadrant quadrant 1. The upper left quadrant is quadrant 2. Down here on the lower left is quadrant 3. And the lower right is called quadrant 4. And so every angle between 0 and 90 degrees and 0 and pi over 2 radians ends up here in quadrant 1. Now, we talked earlier about what 180 degrees looks like. And 180 degrees is just your straight line angle. And we said that 180 degrees is the same as pi radians. And so every angle between 90 and 180 degrees is going to end up here in quadrant 2. And every angle between half of a pi and a full pi will also end up in quadrant 2. Okay, let's look at example H now, 270 degrees. And so what I want to do to convert that is multiply by pi over 180. And so that's going to give me 270 pi divided by 180. And again, we're going to look just at the fractional part of that. Leave the pi out of it because we want to leave our answer in terms of pi. And 270 over 180 will reduce to 3 halves. And so 3 pi over 2 is going to be the same as 270 degrees. Well, where would 270 degrees be? If I start here at 0 degrees, go 90 degrees, that's going to get here. Go another 90 degrees, that will put you at 180. And another 90 degrees will put you on the negative y-axis. And so down here, I'm going to have 270 degrees, which I now know by conversion is the same thing as 3 pi over 2. Okay, finally, letter I, we have 2 pi. And so to convert that from radians to degrees, we're just going to take 2 pi and multiply by 180 divided by pi. That's going to cause the pi's to cancel, and so I'm just going to have 2 times 180, which is going to be 360 degrees. And so 360 degrees is going to put me all the way back to the beginning of the circle. And so 360 is going to be here on the positive x-axis, and that's going to be the same thing as 2 pi. And so this 0 here and this 2 pi here, those are your radian measures. This 0 degrees and this 360 degrees, those are your degree measures. And so this just gives you an idea of where angles are going to fall in this particular coordinate plane. So just for example, just a basic easy degree example, what quadrant would 225 degrees be located in? Well, 225 is in between 180 and 270, and so that's going to fall into quadrant 3. Where would 330 degrees be located? Well, 330 is between 270 and 360, and so 330 degrees is going to fall into quadrant 4. And so the degrees are pretty straightforward and pretty easy, but let's talk about radians for just a second. What if I wanted to know what quadrant 3/4 pi is going to fall into, or 3 pi over 4? Well, 3/4 is in between 1/2 and 1, and so 3/4, or 0.75 pi, is going to be between half of a pi and a full pi, and so this is going to be in quadrant 2. Well, what about something a little bit more difficult? What about like 5 pi over 4? Well, 5 pi over 4 you could really think of as the same as 1 and 1/4 pi, and so if you think about that, we're starting here at the positive x-axis. 1 pi is going to get me back over here to the negative x-axis, and then 1 more quarter of a pi is going to put me here into quadrant 3. And again, just a reminder, positive angles rotate in the counterclockwise direction, and so that means that 5 pi over 4 is going to end up being in quadrant 3. What about, let's say, 5 pi over 3? Well, 5/3 is the same thing as 1 full pi, and then 2/3 of a pi left over. And so again, if I start here at 0 and I go 1 full pi, that's going to put me here. But then if I have 2/3 left over, 2/3 is bigger than 1/2. And this right here is 1.5 pi. And so 1 2/3 pi is going to push me past that negative y-axis into quadrant 4. And so this is going to be a very important skill for us moving forward, is to be able to identify what quadrant a particular angle lies in. The degrees are pretty easy because they're numerical. The radians are a little bit more challenging because they are fractions, and so you have to be able to think of these in terms of mixed fractions because it makes it a little bit easier to figure out what quadrant it goes in.